Okay? So Tyler runs at a constant speed, a constant rate. Okay? And he ran 3/4 of a mile in 2/3 of an hour. What is the COP or the unit rate? Okay, give me a strategy. How would we figure out the unit rate or the COP?
Division.
Division, okay. Could we make a table? Would a table maybe help?
Okay.
Okay, let's try a table. So we're going to put hours in miles. And we know he ran 3/4 of a mile in 2/3 of an hour. And we want to know the COP. And remember, the COP happens when X is 1. And we want to know this number right here. Okay, we've got two options. Can we look at it going this way? How do I get from 2/3 to 1? What do I multiply it by, or what do I divide it by, multiply, whichever way you want to go. What are we going to do? Multiply by the reciprocal. Awesome. So I'm going to multiply that by 3/2, and that's going to give me 1. If I multiply this side by 3/2, what do I have to do to this side? Do the same thing. So I'm going to come down here. I have 3/4 times 3/2. That's going to give me, I'm going to multiply straight across. It's going to give me 9/8. Okay, so this 9/8 means he is going to run 9/8 of a mile, which equals 1 1/8 miles per hour. Okay, that's one way to do it. Does that make sense to everybody? Okay, another way to do it is we've been finding the COP by thinking about y over x. So if I make a y over x column right here, y is 3/4, I'll write it down here so you can see it. X is 2/3. Oh, that looks horrible, doesn't it? Does that look super complicated? 3/4 divided by 2/3. That's all it's saying. If I write it this way, I bet it doesn't look as bad. 3/4 divided by 2/3. Well, when we divide fractions, we are really multiplying by the reciprocal, which is what you told me to do up here. Didn't we multiply this by the reciprocal? Looky here, we end up doing the same exact thing, and we get 9/8 again. So we can either look at it going as a scale factor, going down, or we can look going across, and we get that same 9/8. Okay? Questions you have for me? All right. So you erase that. Go to the next screen. All right, so you should have already watched the video for proportional relationships and equations, lesson 4. Our learning goal was let's write an equation describing proportional relationships. What's an equation? Rebecca, what's an equation?
I actually just had a question.
What's your question?
How do you tell which one's X or Y?
Well, in the previous problem, you mean in the chat problem?
Yeah.
Because we wanted to know the COP, and speed is always per hour. So X is the column that goes to 1 when you're finding the COP. So that's why I put time in the hour column.
Okay.
Okay, good question. All right, what's an equation?
The question of the math problem.
Okay, it is a math sentence. What does it have in it?
The answer?
Okay, it has to have numbers. It has to have an operation like adding, subtracting, multiplying, or dividing. It will have a variable if it's an algebraic equation. And what are variables? Rebecca?
Letters.
Letters that represent numbers, an unknown number, and it has to have an equal sign. Okay? Numbers are called constants, so it's going to have constants, variable, operation, and an equal sign. Okay? All right, so by the end of the lesson, you can write the constant of proportionality as an entry in a table. You can already do that, can't you? How do we do that? How do we find the COP in a table? Chloe?
We can make, or we can, if the table's set up, you can, if there's numbers on both sides, you can divide it or try to multiply it and see what it is, and then see if it works for all.
Okay, can we do y over x? Is that what you're trying to say? Yes.
Yes.
Find that y over x. Then we are going to write an equation in the form of y equals kx. Well, y is the y column. K is the constant. That is the COP that we found. And x is the x column. That is the form that the equation will be in. So the only thing that we're adding on to what we've already done is taking that COP and plugging it into this equation. Okay? Why do we even want an equation? Well, it makes it easier. It ends up turning into a formula. Okay? So we're going to look at a couple of those. So let's look at this table, and we are being asked, what is the COP? Okay? So the COP is going to be, how do we find that? How do we find the COP from a table?
Y over X.
Y over x. So I'm going to make another column here and put y over x. This is x, this is y. So y is 12 over 3. That gives me a COP of 4. Now, also look here. Whenever x is 1, our COP is right next to it. Okay? If you look down here, it's saying R is 4R. Well, how did they get that? Well, if the COP is 4, then R times 4 is 4R. Does that make sense? All right, so how can we write, what does the COP mean in this situation? What does that 4 mean? Chloe, what does the 4 mean?
It's the constant of proportionality.
It is. What does it mean in terms of this problem? 4 what?
It means that you multiply 4 by the red paint.
Right.
To equal the blue paint.
No, to get the purple paint. This is a recipe for purple paint. You need 4 parts of blue paint for every 1 part of white paint or red paint. Okay? Now, whether we're talking cups, gallons, it doesn't matter. You're going to put 4 times more blue than you are red. That's what the 4 means. Okay? Now, to write the equation, remember the equation is in the form of y equals kx. Okay? So our y column represents what? Blue. So I'm going to put B for blue equals, what's my constant? 4. What does my x column represent?
Red.
So I'm gonna put R, where B is blue paint and R is red paint. I have to tell you what the variables represent. Okay, there's the equation. Was that pretty easy? All right, let's look at the next one. What is the COP in this table? Well, where can we find the COP?
B equals 1/4 B.
1/4 B is part of the equation, but the COP happens where X is 1. Or can we do 3/12? And that gives us 1/4. We've got lots of options here. Okay? What does that 1/4 mean? That means if I have 1 part blue, I'm going to need 1/4 of that
Be able to equal the purple paint.
to equal the purple paint. It's a recipe. It has to be the same or the purple won't be the same shade of purple, right? All right, so now we're going to write in
Is this lesson 4?
yes. Okay. Now we're going to write in a
Lesson 4.
what?
I don't
It's
know
not
if
the
that's
practice problem.
It's not the practice problems. It's a review right now.
Okay.
Okay? All right. Now, how do I write the equation? Remember, the equation is in the form of y equals kx. Well, what does y represent in this table? This is x. So we're going to say r equals
1/4.
1/4 of blue, where R is red and B is blue paint. Now, think about what we did in the other one. The other one we had B equals 4R. Tell me about those two equations.
They're reciprocal.
They're reciprocals. Were the tables switched in the other table? The other one had red here and blue here. That's why the reciprocal. Okay? It's kind of like going from big to small and then small to big when we did scale factor. Make sense? All right. All right, now we're going to start on the practice problems. A certain ceiling is made up of tiles. Every square meter of ceiling requires 10.75 tiles. Okay, every square meter requires that. Fill in the table with the missing values. So where am I going to put that 10.75? What does this mean? First column, because this is saying every square meter, that would be 1 square meter, right? Requires 10.75 tiles. If I do y over x to find my COP, I'm going to get 10.75 over 1, which equals 10.75. The other thing is when x is 1, whatever y is our COP. Okay, how can I use my COP to find this amount right here? I'm going from here to here. What am I going to do? What am I going to do?
Multiply 10.75.
Good. So I'm going to multiply these. So take out your calculators and multiply 10 times 10.75. Did you get 107.5?
Yeah.
Okay, you need to come to math class with your calculators, okay? All right, this time I'm given the number of tiles and I want to know the area of the ceiling. I'm going this way this time, so what am I going to do?
75.
I'm going to, Chloe,
Divide.
divide by 10.75. So take out your calculators and take 100 divided by 10.75. What do you get? Round it to the nearest tenth.
9.
To the 10th. 9.3 approximate. Okay, all right. Now, if we have A, any number, any area of ceiling, how are we going to figure out how many tiles we need? Well, when we go this way, what do?
Multiply times 10.75.
And then the way we write that is we put the constant in front of the variable. So it would be 10.75a. All right, I added something to this problem. I want you to write an equation for this situation where A, square meters of ceiling is A and T is tiles. So how would we write the equation? The equation is in the form of y equals kx. Okay, so what is y in our table?
A.
What is y in our table?
T.
T. T is the number. T is the number of tiles. So we're going to say T equals. Okay.
10.75.
10.75 and then A for area.
Do we have to put the A?
Yes. Okay? Because that's representing the area. Now, why make the equation? Well, do you want to draw a table every time they ask us a bunch of questions about how much we need of something? No. If we have an equation, it's like a formula and we can just plug in a number. If I say the area is 1,000, I can just come down here and do T equals 10.75 times 1,000 because the area was 1,000. And I can easily find the answer. All right? See how the equation makes our life a little bit easier, doesn't it? All right, questions you have for me?
No. I have a question. This is not like math, but like for the last one in the box when
Yeah.
I do the A, to put it in lowercase or capital.
Lower.
Okay.
Okay? Variables are always lowercase. Good question. Thank you. All right, any other questions? Who needs more time?
When we put it into the quiz, would we have to, like, if we don't put the A, will it get points taken off?
Yeah, it would be wrong.
Okay.
Because T does not equal 10.75. T equals 10.75a. All right?
Put the A at the end.
If you don't put the a at the end, it's not it's not the right equation.
Okay.
Okay, any other questions? Anybody else need more time? Okay, I hope you're writing down this work and you're not just putting the answers in the computer.
You could screenshot it.
Yep. Because the work is what's important. All right, moving on to question 2. On a flight from New York to London, an airplane travels at a constant speed. An equation relating the distance traveled in miles d to the number of hours flying t is t equals 1/500th d. How long will it take the plane to travel 800 miles? What's the story about?
Flight from New York to London.
Right? And what do we know about the flight from New York to London?
It's traveling at a constant speed.
And that's important because it's proportional. Okay? We also know the equation is this. T is time in hours, and D is distance in miles. What is that 1/500?
The COP.
The COP. That is the constant. All right. Now, how long will it take the plane to travel 800 miles? Is 800 the time or the distance?
The time.
Distance.
Oh, I got both
Distance.
answers.
Distance. Time.
What's the unit here?
Miles, so it's distance.
So it's distance, right? Okay. What are they asking us? What are they asking us to find?
The time.
The time. So the time is unknown. So we're going to leave the t, we don't know that. We're going to plug in what we do know into the equation they gave us. So where am I going to put the 800? Where the d is. The operation between the coefficient and the variable is multiplication. So now take out your calculators and multiply 1/500 times 800. So what is t?
1 3/5.
Okay, and we could write it as 3/5 or we could write it as a decimal. Either way works. Now, you got an answer for t, but you always have to answer in a complete sentence for me. Okay? They asked us to find how long. So it will take, and it can be a simple sentence. What does this 1.6 or 1 2/3 mean? Or 3/5 mean?
How long it'll take to travel 8.
So it will take 1.6 hours. You can just write the sentence like that.
If we want, could we add airplane? Like it'll take the airplane.
Yeah.
1.
I'm just showing you the bare minimum kind of thing that you need. Or you can say 1 3/5 hours.
Okay.
Okay?
Does it matter? It doesn't matter which one you put.
I think I put both answers in there as possible answers.
Okay, so.
I did it 3 days ago, so I can't remember 100%, but I think I put both in there.
Is there a certain one you prefer us to do, or?
I don't care.
Either way, it's right.
Generally, if the decimal terminates, you can answer it with a decimal. If the decimal doesn't terminate, you leave it as a fraction.
Okay.
Okay? All right. Any other questions for me? Yes, Chloe.
So if we put it as a fraction, does it have to be improper or?
It can be, or you can put it in there as 1 space 3/5.
Okay.
Okay? Any other questions?
So basically, it's 1.6 hours.
It is. It's not basically, it is 1.6 hours. All right. Who needs more time?
Okay.
Yes?
You left me on co-host, and it keeps on like telling me who's raising their hand and stuff.
Okay. I'm gonna find your name. There we go. Okay. Problem number 3. Each table represents a proportional relationship. For each, find the COP and then write the equation. How do we find the COP?
Multiply.
Okay, we're going to think about multiplying, but how would we find the multiplier? We're going to find the COP by doing y over x. This is our x column, this is our y column. Okay, so we're gonna do 8 over 2, which equals,
X is always the first column, correct?
yes, X is always the first column. Okay, if we check this, we're told that they're proportional, so all of these should be 4. 12 divided by 3 is 4, 20 divided by 5 is 4, 40 divided by 10 is 4. So our COP is 4. Okay, the equation is in the form of y equals kx. So in this case, y is p. So p equals, what's our constant? 4. And what is our x?
1.
No. S. Okay, so our equation would be p equals 4s. Does everybody see where I got that from?
Yeah.
All right.
Oh, when you go to put the answer in, you want us to put the S also?
If you don't put the s, it's not the equation.
So it's proportional.
Right, it's proportional because it's in this form. Okay, right here.
So the COP is 4, right?
Yes. All right, so let's look at this one. How do we find the COP?
Multiplication?
No.
Divide.
Y divided by x. So what is y? 6.28. What's x? 2.
2.
What does that equal?
3.114.
Okay, so our COP is 3 1400. Our equation, here is y, so that's C equals, what's our COP or our constant?
3.14.
3.14, and what's our x?
Z.
D. So your equation is C equals 3.14D.
So the equation is literally just the number and the other column?
Yeah.
Oh, that's not too hard.
Y equals KX. All right? Questions? Any other questions? Great questions.
What's the letter on the other side?
I'm sorry. You've, over here,
Yeah.
that's an S.
X.
S, as in Sam.
Okay, thank you.
You're welcome. Any other questions?
No.
Okay, who needs more time? Okay, onward to problem 4. A map of Colorado says that the scale is 1 inch to 20 miles, or 1 to 1,267,200. Are these two ways of reporting the same scale? What is the here's one scale, here's the other scale. How are the scales different? What's different about those two scales, other than the numbers? Anthony, what's different about the two scales?
I'm not sure.
Okay, Chloe, help him out.
So one thing I see is the first one says 1 inch to 20 miles, but the second one doesn't give a unit. It just gives the numbers.
Okay, so, and when we don't have units, what do we know about the units?
They'll be the same. For
They'll
both
be the
numbers.
same. If the picture is in miles, that means this is 1 inch to 1,267,200 inches. Now, are these the same scale? How can we figure that out?
Divide 1.
The question is, does 20 miles equal that? Are they equal to each other? How can we prove that they are or aren't equal?
Can't you divide 1,267,200
That's saying 1 inch equals 1 mile.
Right.
How many? Okay, so,
Divided by like 20.
so do we need to,
Actually, 12.
okay, well, if we divide it by 20, that's gonna give us 1 mile. But we still don't know that they're the same. So do we need to figure out how many inches there are in 1 mile? Okay, how can we figure out how many inches there are in 1 mile? So 1 mile equals how many inches? Because then we can figure out 20 miles equals how many inches, okay? Does anybody know how many inches there are in a mile? Okay, does anybody know how many feet there are in a mile?
Isn't it like 1,760?
You're close. 1 mile equals 5,280 feet. That's one of those things you just need to know, okay? So, I want to know in inches though. So what am I going to do now, Chloe?
63,000.
Yep, 60. You multiply this times 12. So I'm going to take 5,280 times 12. And that's going to give me 63,360 inches. So 1 mile equals 63,360. So 20 miles is going to equal, what are we going to do now to figure out 20?
Multiply 63,360 by 20.
Yes, do that for me. Do you get the 1,267,200?
Miss Laird,
Yes.
you know the answer for 1 mile equals 63,360 for inches?
Uh-huh.
I divided 1,263,200 divided by 20.
Okay, and you got that, didn't you? Uh-huh.
Yeah.
So are they the same?
Yeah.
Yes, they are. Because 20 miles equals 1,267,200 inches. So these are the same scale. Because 20 miles equals 1,267,200 inches. Okay? Questions you have for me? Who needs more time?
So which one would be the answer?
Or what are they asking?
Are they scale factor?
No, that's not the
Are
question.
they the same scale?
Are they the same scale? Yes.
Miss Laird,
Yes.
I have a question.
Uh-huh.
It's not about this assignment. I mean, not this practice problem, but I was gonna say, why I hear people leaving. Why are people leaving so early right now?
I don't know.
Because we're not even done yet.
I know. Rebecca, do you have a question or is that an old hands up? Okay. All right. Anybody need more time? Okay. Here we are on the last question. We have this polygon. We are being asked to draw it with a scale factor of 3. Is it going to be bigger or smaller?
Bigger.
Bigger, okay? And it's going to be how many times bigger? 3 times. So if I measure this, we get 2. If I measure with this, we get 2. And I need this measurement right here to be able to do that point up there. And that is 4 if you can't see it. Okay? So to draw this side right here, how long am I going to draw it on my picture?
6.
How'd you get 6?
2 times 3.
Awesome. 1, 2, 3, 4, 5, 6. Okay, how about this side right here? Does that also get drawn 6?
Yes.
Okay, 1, 2, 3, 4, 5, 6. And the one down at the bottom is exactly the same. Then I'm going to go, how far is my distance? 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then I'm just going to connect the dots. Not a very good line, but y'all get the idea. And they told us to label this A. This is 6, 6, and this distance right here was 12. All right. Now they want us to draw a scale copy of 1/2. Bigger or smaller than our original?
Smaller.
Smaller. So we're going to multiply everything by 1/2. So 2 times 1/2 is
1.
1. So that's going to be 1 and 1. And then this is going to be 2. And they want us to label this B. This is 1, 1, and inside is 2. Okay? Is polygon A scale copy of B?
Yes.
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 What is the scale factor to get from B to A? What do I multiply B by to get A?
6.
6. Questions you have for me? Who needs more time? Dominic? Question? No? Okay. I think that was the last practice problem.
Yeah.
Okay. So we have gone over the lesson and we've gone over the practice problems. You do not have to watch a video tonight because tomorrow we are going to take 2 short assessments. Okay? If you are not caught up, then this asynchronous time, this extra 20 minutes, would probably be a good time to get caught up. All right, I will see you tomorrow.
Bye.
Bye.